Let's get this thing started. Okay, everybody, listen, thanks a lot for coming. My name is Scott Morrison. I'm the former CTO of a company called Layer 7 Technologies, which was a startup based in Vancouver up in Canada. And we started about 13 years ago or so, and we were very fortunate about 2 years ago to have been acquired by CA Technologies. So I'm no longer the CTO, I'm now what's called a distinguished engineer at CA Technologies, which of course sounds very lofty, and but I like to be a little more humble. And I left my jacket, with the patches on the bottom and my pipe at home. So I'm not going to be particularly distinguished this time. But you know what I am going to do is I am going to talk to you all about APIs and hopefully get you excited about this, because it's a really, really great new technology. Now, technology-wise, when you think about it, this is a great time to be in technology. I mean, there's a tremendous amount of stuff going on. But at the same time, it's almost one of those times where you have to think about, the old Chinese curse, may you live in interesting times, which sounds great. Of course I want to live in interesting times. But the truth is, interesting times are times of change, and lots of stuff can go bad. And in fact, this is one of those times in technology. It can be interesting, but it can also go very badly for all of us in any organization just because of so much change. And the change, of course, is coming because of disruptive technologies, like the phone in your pocket. And that sounds pretty easy, like there's nothing that big, much of a big deal about a phone. But a phone really went, when you think about it, cascading through all organizations, whether it's in large corporate enterprise, a Fortune 500 company, or a government, and was hugely disruptive. And it left a lot of damage in its wake. And we're only at the start of that. We're also seeing cloud computing come in and be tremendously disruptive to all sorts of IT departments. And the next thing, of course, is the Internet of Things, which everybody promises us is going to be even bigger than the last two giant disruptions. So these are indeed interesting times. And the key to interesting times and the key to surviving and thriving in interesting times is recognizing that there are opportunities. And in fact, we can use things in technology to be great opportunities to make us all successful. And the opportunity I'm talking about really are APIs, which are a way of tying together applications. It's the new way that we make applications talk to each other. This is the way integration is done in 2015. So you may wonder and ask me, Scott, like API, what is this API thing? And the easiest way to answer that is to show you what it isn't. This is not API. Now, I took this picture about an hour ago right outside here, believe it or not. And there's this giant thing, and it's a giant limo, it turns out. It had API on it. I was really excited. I thought, they sent me a limo, finally. I've been waiting my whole life to actually ride around in a giant limo. But that's not very distinguished, and of course I'm a distinguished engineer, and so I just came in my rental car, which is, I think, a little less ostentatious. But this is not the API I'm talking about, and I'm going to use this again and again. I'm just, I'm thrilled that this guy just decided to park right outside Sacramento here. So API, though, for a lot of us who've been in technology long enough, and I've got the gray hair to prove I've been there. It's one of those technologies that you've heard about a lot. It's an acronym that stands for Application Programming Interface. And many of us think, oh, I know this stuff, APIs, back in the days when I was building on Microsoft Windows, there was an API there for Windows and that. And it's true, this acronym has been used for quite a lot of time. But it's gained a new sort of meaning lately, and that's a really important piece of this whole puzzle. So the best way to explain it really is to look at things that we're really familiar with. Like, what's a human API look like? And that's a sort of the interface between a person and a machine. And we use these kinds of APIs all the time. We call them UI. And so if you pick up your tablet or your phone and you're interacting with an app, you're really going through a kind of API in that, you've got little places where you can type things and boxes where the input is constrained. If let's say you have a little type field and it expects a date, it's probably not going to let you put in a dollar amount or something like that. So there's this sense of two things. One is structuring the data, and the data is automatically structured simply because of things like text boxes and choosers and things like that. But there's also the sense of typing and the sense of certain kinds of data will fit in here and certain other kinds won't fit in there. And when you put data in, there's a reaction, and ideally the display changes and something different comes back to you. That's actually an API. That's an API between a person and a machine. But APIs in the sense that we're interested in are a little more complicated, because they're really there for machines to talk to other machines. and that. But the concepts are the same. The concepts of structuring data and exchange going in, and then getting back structured data in return are pretty much exactly the same, in fact. The only difference is a machine doesn't need all of this, fancy UI or anything like that. It just wants the data. It's just about the data. And so really that's what the API is about. So in this case, let's say I had two computers here. I might just basically call one of them and say, give me information about the weather. And I would get back weather in a structured piece of information. And the beauty of this is, this particular structuring is basically a formula called JSON, and it is human readable. I mean, all of us can tell exactly what this means. In the city of London, the temperature is 22 degrees Celsius right now, which is pretty warm. So about what it's like right out here. But it's also useful for the machine, because of course the machine can parse this up trivially easily. And that's an important part of the whole API equation, making things simple, making things, basically understandable by both machines and humans as well. Well, so let's talk about this a little more then. So APIs then aren't really new in the sense that we've had them for many years. They're really just an interface between different modules, a formula and contract for how different modules should talk to each other. And good examples, of course, are things like SQL. I mean, SQL is a kind of API. It's a protocol for talking to databases, but there's a very particular formula for making a query, getting back information. And that query, of course, could just be getting back information, or actually inserting information, or deleting information, or even just updating it. So this interaction where those sort of four fundamental constraints of, create, update, retrieve and delete, what we call CRUD a lot of the time, because we love acronyms in computing, are really what an API is about. And you can do an awful lot if you just basically build things around that concept. In fact, you can do pretty much everything you need to do in computing with just those simple things. But we're not quite there yet. So we have this idea of a contract, and we have this idea of a contract between systems, and we have this idea of a contract that just does four simple things based on the CRUD idea of create, retrieve, update, and delete. But what about the web? How does the web fit in? And this is the really, really important thing that has created this tremendous revolution in the whole API movement and that. So over the years, we've tried again and again and again to get computers to talk and to basically create big distributed networks. We've had, COM+, we've had, DCE, and we've had, all sorts of different technologies like Corba. And you know what? Every one failed. Every one of them failed to scale past a certain point, all except the web. And the brilliance of the World Wide Web, the brilliance of all the stuff that Tim Berners-Lee came out with so many years ago, was that this thing just scales and scales and scales. We can constantly add new systems. We can constantly take away systems. And the damn thing doesn't fall down. It just keeps going. So we hit something. We actually hit a truth. We finally figured out how to do scalable distributed systems. And what did we do? We used it for, browsing cat pictures and things like that. So what if we took that wonderful technology that we've, not really done that much with, and then used it, instead of like going to eBay and buying things, what if we used it for computers to talk to each other as opposed to computers to humans? And that was the great idea behind really APIs. That whole concept that you could take something as simple as the web infrastructure and use it to make applications talk to each other. Profoundly important idea. It came out in the late 90s by a guy named Roy Fielding, who sort of consolidated these concepts in his PhD thesis. And this technology has been around for a while, but for a long time it was kind of this weird sort of cult thing that a few people, the nutty programmers off on the side, were playing around with, and nobody believed they were doing the right thing. But you know what? They were. And let me show you why. So imagine this. Imagine I'm sitting in front of my computer terminal right now, like my Windows system, and I do something like this. I just fire up my Firefox application, and just bring up Firefox, and just into the address bar there, I just type a simple query. Okay. So I'm going to quickly type in that I'm going to do an API query into layer 7. I'm going to call it get person, and I'm going to parameterize it with a name, Scott. Okay. So far it looks a lot like the web, okay? And you might think, well, I'm just going to get a web page back. But instead, what I get back is just structured information using that JSON formula. Now, you're probably thinking, well, big deal, Scott. All you've done is you've showed us, how to use web servers and web browsers and that. But that's the great thing about this whole thing. That's the great thing about this technology, is that all of a sudden you can apply all that same technology and use it for application-to-application communications instead of just using it for, web browser to application communications. Because I can build an app really easily that does that same query. I can embed that query into my app, do that call, and then that app can very easily interpret all of this data down here, which tells you pretty much everything you need to know about me. And that's actually really, really powerful. That's powerful because really it lowers the barrier to entry. It means that I don't need any new tools or technologies. I have them already. I've spent the last 25, 30 years putting up web servers and load balancers and programming my firewalls to let communications take place over port 80 and 443. Those are always open, because if they weren't, we couldn't be browsing the web, and we like to browse the web. So everything is there, and that's a really important idea. Because if I have all those pieces, I can just get to it. It's kind of like this frictionless sort of experience. In other words, I can, as a developer, just sit down and get to work, and I'm not blocked. I don't have to go to the firewall people and grovel and ask them to open up this new obscure port that they're going to get mad about because it's another thing for them to track. Instead, I'm using the existing technologies. Very, very important thing. And in the end, it makes me very agile. It means that I can just sit down and use these tools and get things done. I don't have to load new libraries. I don't have to, bring in complicated IDEs or anything like that, because my web browser is my IDE. Browser is an IDE. And all I need isn't like Notepad or something like that to sort of copy and paste stuff in. And all of a sudden, I'm building apps. And that kind of agility is incredibly important, because you know what matters the most today in 2015? Getting apps out fast, getting apps out the door as quickly as possible. Nothing matters more than that right now. I mean, look at the explosion of mobility and what mobility has meant to all of us. It's changed our perception of how quickly we can get things. And so as IT professionals, as the people who the business are looking to provide leadership, the business is saying, I'm getting all these apps constantly. They're updating and new stuff is coming out on iTunes and everything like that. Why can't you be like that? Why can't we be like that? And so to a certain extent, we have to learn from that. And we have different roles and responsibilities and expectations. We have different compliance regimes and things that we're subject to. But at the same time, we can take inspiration from some of these new, very fast-moving, very agile approaches to doing technology and for getting apps out the door quickly. And APIs really are the key to this. So who started noticing APIs? Well, obviously, it's people like Mark Andreessen. And he said, and this is interesting, he said, we've got browsers on the brain, which is ironic, because this is the man who's very, very associated with browsers. He was really the inventor, or the key person behind the Netscape browser. But he said there's no reason why most of the internet traffic within 5 years can't be computers talking to computers. And he actually said that in Network World. So, a good reputable paper. But when did he say that? Did he say that this week or something like that? He said that almost 15 years ago. Wow. So as usual, he was like years and years ahead of everybody. It's taken the industry many, many years to sort of catch up to that. But the truth is, we're actually getting there, and we're getting there because of this whole API movement. So one thing you may not have even noticed is you're probably using them already. So if you check the weather today, and in sunny Sacramento, you don't usually have to check the weather. You just sort of look out and go, oh, another beautiful day here. Looks pretty good. But that uses APIs. Like here's a good example. Like let's say I just hit that weather app right here, and I pull it up, and I pull up my little picture right here of what the weather's like, and you can tell this is fake because it says that there's 5 days in a row of sunshine in London, which has never actually happened ever in the history of Great Britain. But the truth is, this is an app. This is not this is not Safari. This is not your web browser. This is just an application talking to another application. It happens, though, to be using APIs. It happens to be using, the same protocols, the same infrastructure, the same technologies as the web, but it's an application-to-application communications. And there would be no other way of doing this. We wouldn't bother to do it with homebrewed protocols or anything like that. So why is this happening suddenly? And it does feel like that. It feels like this stuff has just suddenly appeared. But the truth is, it did sit out there and percolate for quite a while. And in fact, when we started Layer 7, we had this vision of everybody was going to be talking using web services protocols like SOAP, and they were big and heavyweight, and they were heavily driven by vendors and everything. And I was a big advocate of all of that. I mean, I was a co-editor of the basic security profile for web services. And you know what? Didn't work. It didn't work because it was so heavy and cumbersome and complex and that. And this is totally different. APIs are totally about the exact opposite. It's about whipping out your browser and just starting to type and trying things out and failing and editing and iterating and things like that. And that's really, really, really important. But a couple of other things appeared all of a sudden that were the real tipping points in that. And one of them is mobile devices. This thing made a huge difference. And I can tell you, having been there for many years looking at our own, we were selling, API gateways, and I'll talk about those a little more in a bit. And we had a good business and it was going along, and then all of a sudden it kind of went woof, like this. And the reason was, all of a sudden everybody had iPhones. And iPhones were using APIs to talk to other systems and things like that. They weren't using SOAP, they weren't using Corba, they weren't using all these other protocols that were too heavyweight and weren't appropriate for wireless communications. They were all using APIs. And so this was one of those lever functions, these tipping points that were so profound, they literally changed the world. The other thing was just competitiveness. After the economic meltdown and that in 2008 and into 2009, all of a sudden companies hunkered down, and then they came out and they had huge application backlogs. And they knew they had to deal with these things as quickly and efficiently as possible using whatever new techniques they possibly could. And that was exactly the same time that APIs were starting to become interesting to people. And so these technologies have been used a lot just to increase the speed of app development, to do that catch up, and to be able to deal with the fact that if you don't do it, that other business down the road who you compete with on a day-to-day basis, they're going to do it and that. So important stuff there. And then finally, actually, I got these in the wrong order. But the other one, of course, is just connectedness. And that's really fundamentally about the whole idea of too many different devices, too many different platforms and that. And we need that lingua franca that lets us tie things together. And honestly, the lingua franca in 2015 really is APIs at this point. So here's something interesting to look at. And it's important because it gives us an idea of how fundamentally technology has changed in the last little while. So we've all seen these kinds of graphs for many, many years. It's the connected devices worldwide. It just kind of shows, when you look at phones and devices like that it's a classic exponential curve. And for anybody in computing, exponential curves should look pretty familiar. Moore's law. Moore's law has stated for the last 30 years or so that every 18 months, transistor density doubles. And about every 24 months or so, you get a commensurate doubling of processor power. And this has driven computing for, ever since Gordon Moore made up the law, and everybody kind of naturally started to follow it. And every once in a while somebody, boldly declares, Moore's law is dead, we can't possibly keep going. And some smart chip engineers figure out how to, keep it going. And it just keeps going, and we get this doubling of technology or doubling of performance power every 24 months. But what's the new Moore's law? The new Moore's law is this thing. It's not about the micro anymore. It's not about chips and chip density and things like that. The new Moore's law is about distribution. It's about devices being everywhere, and that being very important power factors. So in other words, it's not really, the important thing isn't that your laptop is twice as fast as the laptop you bought 2 years ago. The important thing is that in the last 6 months, you've had an aggregate doubling of computing power, within, let's say, your local workforce, simply because of the amount of new devices that they're bringing to bear. So we have to stop thinking about the small and start thinking about the large. And if we think about the large, we have to think about how to make those things communicate. Here's something else that's interesting. Whoops, went the wrong way. This is cumulative app downloads. Okay, so this is looking at the apps that people are downloading from iTunes and the Google App Store and everything like that. Not surprisingly, another exponential right here. And worse, or even better, let's look at this one. This is the total APIs that are registered in a public repository called Programmable Web. And this is something that you can basically, if you create an API, you can go there and you can type in, here's where the API resides, here's how to get access to it and everything like that. It's totally optional. You don't have to do this. It's just advertising your API in the yellow pages or something like this. So it really only represents a tiny, tiny, tiny fraction of the actual APIs out there. But the point is that you get this same exponential curve there. So what we're seeing is this interesting story starting from the macro and the explosion of performance as a distributed world to the explosion of apps and that, to an explosion of the things that tie those together. So this is the new forcing function within technology. This is the thing that just grows exponentially. So more and more what we're going to be interested in is not about the hardware, but about the apps and what can the apps do for us, because this is where the interesting stuff is going on really in computing right now. Now the other thing I promised you was that was sort of a difference in the whole thinking process of how we manage technology and how we manage this resource. And I come from, a systems management background from way back, so I appreciate the issues and things like that that go into keeping the trains running on time in any large organization. But when you think about it, it's totally different on your phone. Like, stuff just updates and it just happens and it's easy. And you know what? It's not being done by the systems manager, the guy like me, who's sort of working out carefully when things are being updated. It's by you. And so one of the big trends that is really important right now is this idea of distribution of responsibility, not to a single person, but it's a smashing of the hierarchy and the empowerment of all of you as the users. So that's a really, really important model, because the users are pretty smart. The users can self-regulate surprisingly well if you build a framework around them so that they can. And part of the genius of Apple, I think, is that they did just that. They created a framework that the users could basically update on their own time and things like that, and it works surprisingly well. It works astonishingly well. Now, part of it is because, of course, it's a monoculture and everything like that, and the minute you get more complexity, it's a lot harder. But there's still inspiration in that idea, and I think there's things we can learn about from that idea. And honestly, APIs are going to be the thing that really ties so much of that together. So if I look at the value prop, it's really about creation of everything, from new applications to new revenue streams and new businesses as well. And the last one is really, really important to me, because I think when you look at it, APIs, I love to talk about them in terms of the technology, and I'm happy to go down and dig deep into whatever questions people might have about that. But I think one of the things that excites me about this stuff is that they're also about creating totally new business models and that. So think about this, like, what about revenue streams? Like, how APIs are just a way of communicating between people, between applications. How can they possibly influence something like a revenue stream? Well, the truth is that there's companies out there that are making money from just their APIs. A good example might be someone like Google. Look at the Google Maps API. Now, most of us use Maps all the time. I mean, I use Google Maps to find out how do I get to Sacramento and all this kind of thing. And I'm using the browser to do that. But, the truth is that underneath the hood, Google also has APIs to get that information. And you know what? It's free to a point. So as a developer, I can sit down and play around with the API. I can build an app that queries those maps and gets the maps back, and I can embed those into my iPhone API and that. But once I hit a certain threshold, Google comes back to me and says, Scott, wonderful that you built this app. We've noticed it's gone viral on iTunes. Everybody's using it now. Way to go. You're probably making a lot of money from it. But you know what? You're using our APIs, and you're hitting a certain threshold. You're driving so much traffic into this thing. It's time for you to share some of your profits with us. And of course, Google's very, very effective at that kind of thing. They've done a great job of it in that, because they have something that's so valuable, that they can actually charge for it. Who else can do that? Well, telcos. Telcos, for instance, have information about where you are based on tracking your phone. So of course your phone has GPS in it, but it also can be tracked by triangulation through the cell phone towers, and that was done for emergency services. So if you phone up 911 and say, I think I'm having a heart up, and you drop your phone, they can track you eventually. And that was a very, very important piece of legislation that went through probably 10, 15 years ago or something like that. So all the phone companies can find you through that kind of triangulation. It's astonishingly accurate too. It works really, really well. Now that's very important information, because that is information that only they have, that they can then turn around and sell to developers on an opt-in user basis. So in other words, any one of you, if I'm a developer, I could build an app that you can use and that would basically find where you are and locate you using telco 911 services, but only if you opt in individually. You have to actually say, yes, I'm willing to let, Scott's, cool new app, track me this way. Now you might think, well, why don't I just use GPS, blah, 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 blah. Well, GPS is very expensive. Like, it uses a lot of processing, like a lot of, juice on your battery. Whereas the 911 service triangulation is actually, surprisingly accurate, works just about everywhere, and it doesn't drain the battery or anything like that. But it's an opt-in service and that, so you have to consider that. But the fact is that nobody can control that. Nobody else controls that information but the telcos, and they don't give that away for free. They actually, generally give that away through an API, but that they choose to, they charge back to the developer. So you as a user don't see any of that charging, like in that payback. But the truth is, it's probably there, and the person who built the app, who, maybe you bought the app from them, has built that into their business model. So you have to look at these things as, do I have information that's of such tremendous value that it may be worth, monetizing in that way? Not everybody does, obviously, but many of us do. Let me just check my time here and see how I'm doing. Another one might be something like consumer reach. Now think about Netflix. I defy you to go to Best Buy around here and find a DVD player that doesn't have a Netflix app on it. I mean, what an extraordinary piece of technology. Like, what they've done is, they've not only have they worked out the distribution model really well, but they also worked out the client model so that they made it so easy to build like receiver apps that it would naturally get embedded into all sorts of consumer devices. I keep waiting for the television, or the refrigerator with Netflix on it. It's bound to happen. And they did it through APIs. They did it through a really, really strong API program there. So it was very, very easy to, effectively create, clients and things like that. And then finally, innovation. Like, really, we all need more innovation and things like that. And most innovation, if you go and see, like, go to hackathons and things like that, people are using APIs now to tie together apps in new and innovative ways that we never imagined before. It's some really, really cool stuff. So who gets involved in all this? And this is really interesting because, as somebody who's been in technology for a lot of years, the users of APIs tend to be a really interesting stakeholder group now. When I look at who brings us in as a company, and I'm talking about the API management group within CA, it's a lot of the time it's the CTO or the CIO, but increasingly, and this started to come out probably about 4 or 5 years ago, it's the marketing department. The marketing department's coming to us and saying, we're really interested in selling these funky shoes or something like that, and we're all about being very flashy and cool, and we want people to download these apps, and they're going to be really interesting, engaging apps, but they have to be communicating back with head office and getting all of this information, and the technical people say you use APIs to do that. So we're coming to you to make sure we're managing those APIs properly. And that's interesting because all of a sudden it's becoming something that's driven completely out of IT. You've probably heard the term shadow IT and groups that sort of work around IT. Well, like it or not, APIs are very often the tool that shadow IT is using to get through firewalls and just get things done and that. So it's worth really sort of engaging those people and recognizing that groups like marketing have a place at the table in that. So I'm always interested in these situations where I sit down, with a customer and I go around the table, and it's not just a bunch of nerds anymore. It's business owners, and it's high-level managers, and it's people from marketing and things like that, as well as the people that I've been talking to my whole life, like the architects and such. So all of a sudden, the scope has opened up quite a bit, and so what I would say is, always consider that the table is bigger now. And there's more stakeholders than ever before. So let me talk a little about the the nitty-gritty technology. So I'll leave the marketing stuff and that behind, and talk about why API management matters and that, because this is an important part of the whole equation. So imagine this is your organization, IT resource. Kind of up there in the upper right, you've got a couple layers of firewalls, a typical DMZ, and then lots of back-end servers and things like that. Now, in the past, when I wanted to share that information, I would have all sorts of problems. I would need to break through layers and layers of firewalls, and then all of a sudden, I would have to worry about exposing all of those back-end servers, to the full blowtorch of the outside internet. which of course can, take down all sorts of different systems if they're not, suitably hardened and this is a big attack vector, obviously. So there's lots of problems with that. And the other problem is one of just heterogeneity. I'm not sure if I'm pronouncing that right. I just got too many damn systems in the back. I've got like Java systems, I've got some .NET in there, I've got a Ruby on Rails system, I've got a legacy mainframe. They're all different. They're all different and they all have different perceptions and how they should protect themselves and everything like that. And that complexity creates a security nightmare, because if I'm trying to harden those systems so that they can withstand potential attack from the internet, I've got heaps of trouble. So what I really need then is the idea of an API gateway. So in other words, a layer that sits in front of all of those back-end systems. And this, a gateway like this can take many different forms. It could be hardware, sort of I'm showing you like a hardware style gateway, but of course it could also be like a virtual gateway. And in fact, that's one of my favorite ways of deploying any kind of infrastructure right now, which is just basically taking a virtual image and running it just about anywhere. I've got one, of our API gateways that I just run on my laptop. It runs on my MacBook, and it's exactly the same as one of the hardware devices. Now, these gateways really act as a proxy. So in other words, they insulate back-end systems, and they become like the gatekeeper. So they check the identity of every transaction coming in and make sure that it follows a whole bunch of rules. And if you think, well, it sounds kind of like a firewall. Well, it starts there. But the truth is that it goes much deeper than a firewall ever can, because it really understands much more about the characteristics of an API transaction that are very, very peculiar to the API than a firewall ever could, because it understands application layer programming and application layer communications. So it knows how to authenticate somebody, how to identify them, and how to apply access control lists and things like that. Like, in other words, are you authorized to use this thing? It can also actually check content and make sure that it follows that model. Like, remember the very beginning when I was giving you an example of the human API, like just the user interface that looked at a parameter and said, oh no, sorry, you can't put a dollar amount in the date field or something like that. These kind of devices can do exactly that. They look at those parameters and make sure they're exactly what they should be. And you think, well, why does that matter? Shouldn't the application do that? And I would say yes, but if you can catch it at the front door, you can actually stop the application from having to worry about that. And furthermore, you can protect the application against itself if it's poorly written. You've probably heard about buffer overflow attacks and things like that. It's a very, very particular, typical kind of attack is to try to send information into an application that it doesn't expect and see what it does. Many of them will choke, but many of them will try to interpret it in one particular way and then do the wrong thing. SQL injection attacks are a great example of that. It's an attack that you hear about all the time. Probably most of the big, great hacks that have happened in the last 10 years, actually probably 20, 30 years, have been through SQL injection attacks, manipulation of badly written programs using SQL in parameters and sort of forcing systems to do unnatural acts, really. This way, if you check everything coming through the front door and make sure it's got a very, very rigid schema. In other words, if it's not what you were expecting, you just kick it to the ground. It's a very, very powerful thing, and it gives you a very strong security stance.
Question.
Yeah.
So how is it different in application environment, like inspecting all the SQL injection and all that stuff, and front-side scripting and all that stuff? How is it different?
How's
Is
it
it more specific optimized for API?
Yeah, exactly. So a lot of API, the thing about APIs is that they have a whole bunch of very particular issues and things like that. So, you mentioned a few of them, like injection attacks, like cross-site scripting and SQL injection. But there's a lot of other things in APIs, too, beyond just the security part of it, that I think is really interesting. And that gets into the whole overall management of the API resource itself. So another good example might be, beyond security, what happens if you want to create new APIs and create new views of APIs? So what if I have, let's say, I invested a lot of money in SOAP APIs, 10, 15 years ago or something or so, and I want to convert those into sort of a more modern style of JSON-based API with, let's say, an OAuth token coming in there. So the other thing you can start to do with API management is begin to map these things dynamically. So you don't change the back ends, because the last thing you want to do is open up code that's been working fine for the last 20 years. What you want to do instead is create a facade on top of that and sort of dynamically remap things. And we have tremendous number of customers that do exactly that. You can rethink the granularity of some of your back-end services. So a single transaction coming in can be mapped to 4 or 5 little microtransactions in the back, and all of that data can be consolidated back up and sent up to the the caller once again. So beyond the security thing, there's a tremendous amount of sort of value in actually enabling new APIs and things like that, which typically you don't usually see in just a pure play security product.
So for authentication and authorization, does this support like authentication, a federation authentication model like Facebook or Google?
Absolutely, yeah. And those typically use technologies like OAuth, which are fairly new, moving very, very fast, and quite frankly don't interoperate very well. Like OAuth is a complete mess when it comes to trying to integrate with different back-end systems, and so there's a lot of tweaking that needs to get done on an individual basis. And I know at CA API management we've spent an awful lot of time making sure that we've made it as easy as possible to do exactly that. So if you happen to want to bring in social login or something like that, and you need to map that into maybe a different identity internally, you can create those mappings on the fly, which is very, very powerful.
Is it true that the JSON Web Token is more secure than the Web Token?
I wouldn't say more secure, I would say different. So a JSON Web Token is mainly used for I would say like an attribute-based authorization. Like it's kind of like SAML with the author. Like if you ever use the attribute assertion within SAML, which says not necessarily who I am, but what I am. What are my characteristics? I'm a distinguished engineer. I live in Vancouver. My office is on the 4th floor. I can start to create access rules based on those. So it's not as much about who I am as much as about what I am, and that's really important if you're in a world where people move around a lot, people change. The military is a great example of that. Like they use things like pay grade, or rank as a means of deciding whether somebody's going to get access to something or not. Not as much about Private Morrison, 3rd class or something like that, because I may be gone next week and that. So there's so much, so much movement around in terms of people. It's more important to actually create things like authorization based on characteristics, because characteristics don't change. And so rank and pay grade and things like that just are nets that basically catch everybody and that. And then the people can change around quite a bit. So JSON Web Token is much more about things like that. It's much more about basically creating authorizations and that, and then using those authorizations creating attributes, and then using those attributes for authorizations. Whereas OAuth is very much about almost like a tracking token on an act of authentication. So slightly different uses than that. So here's where they typically live. Usually you just stack them up in a DMZ or something like that. Again, I'm showing them as hardware here, but usually gateways like this are software or virtual appliances. I just kind of like the hardware icon, to be perfectly honest, and that. So edge of the network, but it's really about integrating everything together. Whether it's information, state and local government, whether it's information out in the cloud, whether it's mobility, or even things like trucks and that are all being tracked. So we've got to the point where we're doing really well in terms of just pure play security and making APIs available. We've got kind of the border control concept down. But how does that help me get APIs out faster? I mean, APIs by their nature help me build apps faster. But there's one piece missing, and that's the piece that reaches out and governs access with all the third-party developers. And this is something we call the API portal. And it sits beside basically the whole API gateway. And it's there to reach out, engage the developers, tell them what's available, but also control their access and that, so that you can manage them. Because remember, this isn't a world anymore where all of the people doing development are part of your organization. So if they do something wrong, you basically deal with them as you would any employee who does something wrong. These may be third parties who you have no real control with. You have a very arm's length relationship with. Some people who may use your APIs may just kick the tires, try them for a couple of days, and then you never see them again. Where some come in, build some viral app that everybody loves and drives lots of business for you. And so you want to create a deep relationship with those people. So the portal is really about that. It's about creating that relationship with third-party developers. And the truth is, you know, when we started building things like portals, we thought, oh, it's just going to be for, you know, third-party integrations and people who don't work for your organization. But the truth is, about half of the people that bought this thing, you know, ended up buying it specifically for just internal users because they have the same problem. You know, they need a place where a developer can come in, learn about APIs, find out exactly how to call an API, request access so that they can build against that API, because you don't just want to make it available to anybody. You want to be able to track them. You know, you want to see what their usage is. You want to give the developer access so that they can monitor their, you know, their app's usage. So if they put an app out there in the App Store, and maybe they work for your, you know, state government or something like that, they can then just follow it and make sure it's running the way it should be. And if they happen to notice, whoa, there's a big spike at about 6 p.m. every day, they can think, well, why would that be? You know, and start to think about usage patterns and things like that and refine and iterate on their app. So really, really important things there. I've just got a few more minutes, actually. So what I'll do is quickly wrap up and give you a bit of a glimpse into the future. So we've got this idea that, number one, APIs are really important for integration, and you know, we've got the concept of the API gateway as being the border guard, the enforcement point, and then we've got the whole concept of the portal being out there to integrate, like to engage developers. So what's going to be going on soon? Well, the next big thing really is the Internet of Things, and I want you to think of the Internet of Things as you know, potentially tying everything into the internet, whether it's that projector over there, the thermostat on the wall. You know, we have great companies like NIST, who Google bought, you know, who are real pioneers in that area. Your car, all of these devices, all of these things are going to be internet connected. And how are they going to communicate? They will communicate with APIs. And honestly, I'm not just saying that to be self-serving. This is exactly what we're seeing all the time. There's no reason to be like inventing new protocols and things like that. Maybe on some of the lowest level of the control systems where we've got, you know, very restricted, you know, little 8-bit processors and that, and industrial controls and things like that. But there'll always be a step-up point where the minute it's on the internet, it's going to be using APIs as a means of communication and that. So the Internet of Things is tremendously important because it is going to be tied together, you know, with APIs, or at least I should invert that and say APIs will be even more important because they will be, you know, the substrate of the Internet of Things and that. So definitely something to keep an eye on. The other one is something called microservices, which we're seeing a lot of, which is this whole idea promoted by Martin Fowler, you know, of the whole agile movement and everything like that. And this idea is that in the future, most of our applications are not just going to be these standalone compiled things, but truly will be composed of many, many different parts, you know, all over the internet. And you know, so it may be your application that you see as, you know, the thermostat on your wall, you know, looks like just one thing, but in truth, it's talking to other systems in your house, and it's talking to the cloud, it's talking to, you know, servers that are telling it what the outside temperature is and all sorts of things like that. So it's integrating a huge amount of information together in that. So these distributed components, and it very much sounds like the whole API thing, and it really is, are going to be very, very important. And what we're going to see more and more is this idea that all of this sort of policy enforcement, and so in other words, all the enforcement that I've been talking about as you know, gateways at the edge of the network, will start to push down. And so it's sort of co-located with these devices and that. And so this is something we're going to see in the future, you know, more and more. And so the big challenge here is how do you manage all of these, you know, vast distributed network of services and APIs, which sounds very easy to do, but of course is going to be, you know, the next great challenge for all of us. Personally, the way I think it'll work out is the Internet of Things and microservices and mobility are all sort of part and parcel of the same story. I think they all, you know, have characteristics in the same narrative about distributed computing, which really goes back to that, you know, that great driving exponential that we're going to see of you know, the future of computing really being about distributed systems. So with that, you know, quick summary. I mean, this is the way we're doing things now. You know, I would you know, caution people about, you know, continuing to invest more and more and more and more money into, sort of older ways of integration. The truth is the future is paved with APIs. And the reason to do it is just because they're simple. They're simple, they're easy, and they don't take a lot of extra technology or anything like that. So with that, I'd like to thank everybody. I know, there's a lot of good stuff going on. I really appreciate you spending the time with me here today. I'll be around for the rest of the conference, so I'm happy to talk to everybody. I know we're running pretty tight on time here, but so if you have any other questions, we can maybe take them offline or whatever. And I hope the rest of the conference is great for you. So thank you very much.